Everybody, thank you very much for your attention. Ms. Stamimira, will introduce yourself. Wonderful developer advocate from MongoDB.
Thank you.
Hey.
Thanks, everyone, and welcome. I'm going to mute that. Yeah, okay. Cool. So my topic today is serverless, which I guess is a good follow-up from footer. We're all here talking about Google technologies. I will also talk a little bit about MongoDB because I work at MongoDB, as you can guess from my sweatshirt. Yeah. No, yeah, okay. I'm also a Google developer expert for Angular, where we'll have just a little bit of Angular for everyone who loves web development. And before starting, I have a little promo for the Dublin user group that we have over at MongoDB. So if you're into databases and you want to check out one of our events, check out this page or just Google it and you will find it. All right, let's jump right into it. Before talking about serverless, let's talk about what it's the opposite of serverless, server for servers. I don't know. What is the problem that serverless is trying to solve? So the problems that traditional development models have are many, but the ones that serverless tries to solve are the fact that, first of all, managing and creating infrastructure and configuring infrastructure is a non-differentiating work. It is not something that we are paid to do, in a sense that our clients are paying our companies to see features and to use our websites. And managing infrastructure is not something that is bringing any business value to our company. Also, when we manage to provision infrastructure, we take a wild guess on how much we will need, how much storage, how much compute power, and we might not always guess right because application demand is not predictable. We might have spikes. They might be expected, such as holiday spikes or spikes because there is a World Cup and everyone is trying to access live score and see what is the score. So this is expected. But spikes can be also unexpected. Something might happen and someone or a billion of people suddenly become aware of our website and start to try using it. And it goes down because we didn't predict this increase in demand. So this is what I mean by application demand is not always predictable. The third problem that we might have is that we might over provision. We might say we will need 500 gigs of storage and then we don't use it. And this can be quite costly. Why should we pay for something that we're not using? Doesn't really make sense, right? And this is where serverless comes in. It's a term that is very marketing sounding because honestly, we still have servers somewhere running, but just we are not the ones that are managing them. So when you hear serverless, it doesn't mean no servers. It means that you're not managing the servers yourself. How many of you are familiar with any serverless technology? Okay, that's great. That's great. So the next questions will be for you then. Serverless has 3 core principles. Can someone guess what they are? So I'm gonna need a volunteer to be very brave and say their guess. Okay, you don't have to maintain the server, you don't have to manage infrastructure. That's a good guess. That's one of the principles. Perfect, perfect. Improve development experience because you're not wasting your time managing infrastructure.
Location transparency.
What is that?
Location transparency.
Can you elaborate on that?
You don't care where it's being hosted, which
Yeah, I don't have that on the list, but it's a good answer as well. Yeah, that's a good one as well. And one of the technologies that we'll be talking about, Cloud Run, solves that problem in a similar way by using containers as well. Yeah, that's a very good selling point to serverless. You only pay for the resources that you're using. That's good. That's good. You have no? Okay. Okay. no, well, you do have deployments. You can automate them. So, okay, number one, improve development experience. You're not managing infrastructure, and this accelerates the development process. Second, you have auto scaling. If demand increases, your service can meet that demand by provisioning more instances of your website, or by automatically increasing the resources that are needed to handle the demand increase. And what is equally important, when the demand decreases, so when requests stop coming in, the serverless platform will take care of tearing down the resources that you're not using, so you don't have to pay for them. Which comes to the third principle of serverless. You're only paying for what you're actually using. And this can mean a different thing depending on the platform that you're using. If you're using a compute platform, you will be paying for processing power. If you're using a serverless database, as we are going to see, you're going to be paying for the storage that you use, or the read and write operations that you execute. But yeah, the most important thing is that you're only paying for what you're actually using. All right, so this is a more simple definition of serverless. If a technology is serverless, we can take for granted that it automatically provisions resources and scales also automatically. And I stole this slide from a Google presentation, a Google Cloud presentation. So I hope they don't come after me for any, yeah, it will be fine, right? It will be good. So the thing that the Google Cloud serverless platform offers is that scaling, is VM provisioning, is any kind of security for your application. And the thing that you want to focus on, and you only focus on when you're developing your application, is actually building the code and managing the performance, and taking a closer look at your build so that you don't be surprised. And the serverless technology from Google Cloud that I'm going to talk about today is something called Cloud Run. As Rick mentioned, there are a bunch of serverless things in Google Cloud. They have cloud functions, they have Cloud Run, they have RPG, and so on. But we will be talking about Cloud Run. It is a fully managed serverless platform that works on top of containers. And this is what it offers. It is super simple. It's fully managed. You throw your code there, you bundle it in a container, you throw it, and it starts working. It has consumption-based pricing. So again, you're only paying for the time where your requests are being handled and the processing power that is being used while they're being handled. And it supports any programming language and any runtime environment, again, because of containers. And that's all very nice. It sounds a bit marketing though. So let's see as developers what it actually does under the hood. So we have our application that we want to host on Cloud Run. We have our source code. We have certain dependencies, certain static assets. This is everything that our application needs to run. And this is how it runs on our own server. To make sure it runs everywhere, we will build it and package it as a container image. Usually you can use Docker or build packs to build your application and package it as a container image. Being a container image ensures that it can run on any environment. So it's a self-contained piece of software that can be executed anywhere. And it contains everything that our application needs to be executed and to be running. So we have our container image that we prepared, we built it, and we usually have to upload it to cloud storage if you're working with Google Cloud and Cloud Run. And we also define some environment variables that may be needed for our application. So then we take all that and we add it to our Cloud Run service. And we create a new revision of our service, a new version of this application. Now this Cloud Run service takes it from there and makes sure it scales and it works. So we have our service, we have requests coming in. So important part of the container is that we need to have a port open that can accept HTTP requests. So for example, if we're building a web application, the most simple case for this HTTP open port mental model is that we have a web application and people are trying to access it. So requests are coming in. Cloud Run takes the service revision and out of the image that we provided creates a new container instance. And this container instance can now handle the incoming requests. The container instance is not destroyed right away. It's not like just a simple function, a cloud function that runs and then it's gone and we don't have any idea what happens with the state. It can stay there for a while, but we shouldn't be expecting it to stay there forever. So we need to take into account that it's something temporary. So we can't have the storage and the resources running forever. So if we have some work that happens after we return a response to this request that came in, we have to accept that it might not finish. So if we have some calculations happening after we return, we have to make sure they finish up quite quickly. Then what happens next is our application becomes super popular and people start using it. They start sending a lot of requests at the same time. And what Cloud Run does is it creates a new instance of our container, a new instance of our application. And it can do that up to 1,000 instances by default. This is the default number, 1,000 instances. You can bring it down, you can request more to be created, but this is what happens by default. So it's like super scalable, right? So more requests come in, more instances are created. Cloud Run makes sure our application remains responsive. And what's even more important is that when requests start disappearing or the demand decreases, Cloud Run will start tearing down these containers. And when everyone stops using our website, it will even tear down the final instance. It scales down to 0. So if no one is using your service, you won't be paying anything. What happens if we change something and we want to deploy a new version? Well, we built a new container image. So we run the same build process with Docker or build packs, depending on how we configure it. And we built a new container image. We upload that to Cloud Run, to cloud storage, and then we add new environment variables or maybe the same environment variables. And then we add a new revision to our Cloud Run service. So now we have 2 versions of our application. How do we decide which one is being used? Well, this is configurable, and this is actually pretty cool because we can configure things such as gradual rollout or even rollbacks, because we have this instance, this revision over there, so it never goes away. So if we want to have 100% requests in service 1 revision, and then service revision 2 comes in, we might want to redirect just 20% of the new requests until we are sure that everything is working correctly. And then when we ensure that this is the case, we might redirect all the incoming requests to the new revision. Same way we can perform rollbacks. Or if something is wrong with our new revision, we can just route all the incoming traffic back to the old version, and that's all we need to do. It's pretty powerful. All right, everything's good. We have some application running. We handle requests, we handle responses. That's all good, but what happens if we need to store some information like every modern application in the world does? We need to use some persistent storage solution, something like a database. And the problem with, well, not a problem, but like the model of this serverless service that we're using is that all the instances, as I mentioned, are temporary. So we can't really have a database running inside this instance. First of all, it will be kind of slow to set up a new database every time the container starts and tries to store something there. And it will also be just ineffective and not working because every time Cloud Run tears down a container instance, our data will disappear. So we can't store data on the container itself, on the container instance. We can have a running database somewhere else on another server, And we can just connect to it from the container instances. But this is a very interesting situation here. And if you've seen any like architecture course, you might have seen this kind of a diamond that happens. So you have a lot of requests that are distributed. You have a lot of application instances and everything is fine. And then you add a bottleneck to your system, which is the database, and all the requests are going to the same place again. So what happens here? We start sending a ton of requests to our database. And what might happen is that we might overload with the database. And multiple things can lead to that. We might open a lot of connections and the database might not work very well with 1,000 open connections to it. We will have race conflicts because we're trying to access similar resources. We might have other problems. We might simply not have provisioned enough storage and we might run out of storage. And because traditional databases are not serverless by default, we have to go and manually provision more resources. So these are the not really problems, but this is the situation with using a traditional database. First of all, we don't have auto scaling. We have to go there and provision manually more resources. You can configure like some cloud databases to make sure that they automatically increase the storage space when you start running out of it, but still you can't really manage incoming connections automatically. You have to have some sort of application code that makes sure that we're not overloading the database with many connections and so on. So it's not really serverless. It's not really managed. We can just configure space. Again, we need to provision resources manually, and it can be a potential bottleneck in our serverless architecture. And honestly, there are a lot of ways to solve that with traditional relational database management systems and a lot of hacks that people have thought of, because serverless has been around for a while and people know how to kind of make it work with traditional databases, but why should we? This is why MongoDB has introduced a new product called serverless instances. So first of all, MongoDB Atlas is a cloud platform that allows you to store your data in the cloud, and it also has a whole set of data services that you can use to develop your applications. And the whole idea behind serverless instances is that they can easily work with other serverless technologies, and you don't have to think about all of these things like many incoming connections. How do I handle that? Running out of storage, how do I handle that? How do I prevent the database from becoming a bottleneck in my system? You just use another serverless technology. You just make a serverless database and use that. It provides you with the same things that other serverless platforms provide you with. So you have auto scaling. It is consumption-based pricing. So you're paying for the storage that you're using, you're paying for the backups that you're doing, and you're paying for the read and write operations that you're executing. And finally, it is built on top of the other database offerings that MongoDB has. And I will show you how to create a serverless database. So I have this video, but I'm not going to run it. I'm just going to go ahead and show you how you can do it yourself. So this is MongoDB Atlas. If you create a new account, this is what you will see. It's free to create an account. You don't have to provide any billing information, no credit card, nothing like that. So you can just go ahead and register for free. And this is the screen that you will see when you log into your new account. So you have your organization here, you have your project here, and this is your database deployment list. So let's build a new database. You have a couple of choices here. First of all, you can start with the shared instance. It's free. It will be free forever as well. You don't have to tear it down when you're done working with it. you can just play around with MongoDB Atlas and use the shared instance if you want. The second option is the dedicated cluster option. Here you have storage just for you. You can choose again from different tierings, and it's perfect for like production applications and heavy uses. You also, when you choose the dedicated option, you can choose to distribute your data across one of the 3 major cloud providers. And you can even select regions in different clouds. So you can have one region in Google Cloud in Europe, another region in AWS in the US, and even a region in Azure, wherever you want. So you have this multi-cloud option here. And the third option is serverless. So again, with serverless, you're just paying for the resources that you're using. So let's create a serverless instance. Because it's a slightly new offering, we have a choice of just a few regions, but we're trying to add more as time goes by. So we're going to choose Google Cloud as a provider and the region in Belgium here. Then you have to select a backup. You can select some backup strategy that you want. And finally, you just give a name to your serverless instance. You create an instance and it's being provisioned. Now, by default, the instance is completely locked down. So if you want to access it, you need to create a database user and configure network access as well. So let's create a new database user here and generate a password for it. And we can select a built-in role. So we want to be able to read and write to any database in this project. And yeah, you can even add custom roles. It could also be a temporary user. So if you want it to be working just for 6 hours, you can configure that and it disappears after that. And the second thing that we need to configure is the network access. Now, this is a tricky part with serverless instance, is that they don't currently support peering. So you can't configure a VPC to connect to your Google Cloud application. And they also don't support like private endpoints, but you can configure this for dedicated clusters. So that's why we will add an IP address entry here, and we are going to allow access from anywhere. But this is fine because we also have the database user. Well, it's not really fine, but this is the situation. All right, so we have the network access configured, we have the database access configured, and we have also our database. It takes a couple of minutes to be provisioned, but after that, we will be able to access it. All right. So a little bit more about pricing. And this is a very tricky part when you're working with any serverless platform. You have to take into account how you will be using the data or how you will be using the platform to make sure that it actually fits your needs. So here with MongoDB Atlas serverless instances, you're paying for read processing units. So every time you do a query, you pay for it. This is the number of read operations that you execute against the database. So one read processing unit is one query of like just processing one document. And you pay 10 cents for a million such requests. And it is also tiered. So the next 500 million requests that you send are cheaper, and the rest of the requests after that are even cheaper. And then you also have write processing units, which are the same, like the same model. You pay for storage as well for backup. And we also pay for data transfer if you want to be uploading or downloading any data in batches. So this is kind of the pricing model. So before using this, make sure that it actually fits your demands. And the cool part is that like the cost is not linear. As you saw, we have tiered costs. So when you start using it and you exceed 5 million requests, it actually becomes cheaper. All right, this was the database part, but let's see how that fits into an actual application. So let's deploy a mean stack application to Google Cloud Run. First, what is the mean stack? It stands for MongoDB, Express, Angular, Node.js. It's a tech stack that has been around for like 6 or 7 years now. So on the client, we have a web application that is using Angular. The web application communicates through a REST API with a server that is built on top of Node.js and Express. And that server, on the other hand, communicates with the database, which is a MongoDB database. And in our particular serverless architecture, we will have 2 services in Cloud Run, so 2 different instances. The first service will host our server application, Node.js and Express API. And the second service will host our web application. The server application will communicate through a driver with the serverless instance that we just created in MongoDB Atlas. Cool. So how do we get started with Cloud Run? First of all, go to your Google Cloud Console, enable Cloud Run, enable Cloud Build as well. And then here I will take the easy path and go to the Cloud Shell editor so I can manually change the code and create the deployment from there. So we have the Cloud Shell editor, which looks like a VS Code in your browser. And yeah, you'll be pretty close if you think that is the case. And here in our terminal, we will fetch the code for our application from GitHub. So I'm going to do a git clone and I'm going to fetch the application code. After I do that, I will see that I have the code in the virtual machine instance that is provisioned for us. So we have 2 directories. We have client and server. And in each of these 2 directories, we have a Docker file. So this is the template for the container that we want to build. Now, we don't have to be expert with Docker or containers to use this because it's honestly pretty simple configuration. So if you just want to ship a web app or some simple application, you can find any template Docker file on the internet, and it will give you a pretty good direction on how it works. So let's take a look at the server Docker file. Okay, you see that. So first we are selecting that we want to use Node.js 17 inside our container. Then we are specifying the working directory inside the container. Then we copy the package.json, which is the file containing all the dependencies for our server application, and the package walk.json, which contains also the dependencies with their specific versions. We run an npm install inside the container. So we have the dependencies, we install them. Then we go ahead back to our application and we copy the application code. And then we run the application. This is done in 2 steps because Docker is very clever and it caches some of these steps. So if we do a change only to application code, it's not going to run the npm install again for us. It's going to start from this step. So it caches some results. So if you see that in a configuration, it's because of this reason. And then finally, after we have built our application, we just run node server.js and we start it. So simple as that. All right, the second Docker file that we will take a look at is the Angular client Docker file. It's pretty similar. We have just one additional step here. Again, we configure Node.js, we set up the working directory, we copy the package.json, run npm install, then we copy the application and build the Angular application. The additional step is that we also need to configure Nginx. So we configure Nginx 1.17.1. We have an Nginx configuration that I won't show you, but again, it's literally a template configuration. So we copy that and we start the Nginx server. All right. So we have the two Docker files. Now we will use them to build a container image and simultaneously deploy that container image as a service to Cloud Run. So you can do that from the Cloud Shell editor. You go over here, then you go to this little icon here, and this will create a new configuration that you can deploy. Service, we are creating a new service. We have no services, so then we have to give the service a meaningful name. Then we choose the deployment platform. We will use Cloud Run, and here you would want to select a region that is close to you and also close to your database. So in this pre-recorded video, maybe US East is not the best option because we deployed our database in Europe. So you typically want them to be close. Then we will allow unauthenticated invocations because it's easier to show in a demo, but it's not that hard to configure in production. Then we specify the container port that the service will use to listen for any incoming requests. And here we are gonna add one environment variable. In this environment variable, I will configure the database connection string. So we have this Atlas URI, which is the name of the variable, and then we have the connection string for our MongoDB Atlas serverless instance. You can also use the secret manager, which is another service from Google Cloud, and very easily manage secrets across multiple services there. So we have our URI here. Typically, you would want to add your username and your password, but I'm not going to show you that on the video. And then we choose a build environment. I choose Cloud Build because that's enabled and it's just easier to set up. Then I choose the builder for my container, and here from the dropdown, I will see all the Docker files in this virtual machine. So we will select the server Docker file and then hit deploy. We can watch the logs, and it takes maybe less than a minute actually to deploy this service because there is nothing much in it, to be fair. When it's deployed, we will get back an URL. And this will be a publicly accessible URL because we configured that the service will be available to the internet. So we enabled unauthenticated access. So if I go to the URL, I should be able to access the API that I have created that is for my application. And in this API, I'm simply returning here the employees from the database. So we have an array with employees. And that's it. That's what it takes to deploy a Node API to Cloud Run. Configure a Docker file, clone the code, and just run the service. Then we will do the same thing for our Angular application with one small difference. Because we are accessing the API from the Angular application, I need to get the URL and actually configure that in the server in the client code. I would just hard code it. Again, probably not the brightest idea to do that, but if it's an authenticated URL, it doesn't hurt that much. Again, you can use the secret manager to do that, but yeah, your users will see in the DevTools anywhere where you're sending these requests. So I'm just gonna hard code it here, and then I will go back to Cloud Run and create a new service. All right, so we have service settings. Again, we are creating a new service. We will name that service Angular client. The deployment platform, again, Cloud Run. We'll choose the same reason because it makes sense for the services to live in the same region. I chose a different region for some reason. Again, we want unauthenticated access. We want Cloud Build. And once again, we are choosing the Docker file for the client. All right, we hit deploy. It takes a bit longer because web applications and more specifically Angular applications are slower to build. And yeah, it installs a lot of NPM packages. But lucky for you, this is a video, so we're gonna skip all that waiting. And in just a second, we will have our deployed URL. All right, this is the deployed application. Again, we see the same two employees that come from our database through the API that we are accessing. And yeah, that's it. We have a new working web application with Cloud Run and MongoDB Atlas. All right, and in conclusion, like the actual answer that I want to answer today is when do you need to use a serverless database? And obviously one of the choices is MongoDB Atlas, but I mean, there are other choices. But when you think about it, when you want to use a serverless database, you want to be handling a lot of unpredicted spikes, but you also want to take into account how much you are willing to pay for these spikes. And second, you want to be thinking about how much resources you are willing to pay for as well. So you might be very fine with using a dedicated cluster or by using some cloud database that has enough storage for you. So yeah, in general, serverless database is good for application development and testing because you're paying less and you're not paying per month, you're paying only for while you're developing. And generally this will be the cheaper approach. Also, it's good if you have sparse infrequent workloads, or for example, if you have a CI job that is running every night, it will be good to use a serverless database for that because you're using just a little bit of resources just once a day. And if you have unpredictable workloads, it's also a good solution. But again, you have to take into account how much you're willing to pay for that database. And something that is very important in serverless platforms, and it's true for Cloud Run, it's true for MongoDB Atlas, you want to configure alerts that go to your email whenever your resources go a bit too much. Yeah, that's the final. Okay. All right, so this is a blog post on the topic about Cloud Run and MongoDB Atlas, and also how to configure a MongoDB instance. So if you want to find out more about the topic, you can scan that. And yeah, that's everything I had for you. Thank you.
Questions?
Yeah, sure.
Wonderful. Who else wants to ask?
So yeah, you had the point about infrequent workloads. I wondered, does it scale to zero? Like, will it scale to nothing if nothing's reading it, or will you still be maintaining some sort of single instance, the data structure? Okay, and would that be from a cold read? Would that be very slow? And is there any chance of a loss on a write? Okay, right. Okay, cool. Thank you.
When it shared to the zero, will I wait for spin up again when I'll apply? Yeah.
You're paying for the storage?
No, I mean, when it's scaled to zero and there is no resource used and next request is coming, will I wait until it will be ready to work on this request?
Yeah, so the serverless system won't wait because it's not really scaling to zero. You're just not paying for it. So it will be just their pre-warmed running instance that you're not paying for. And for Cloud Run, there will be some wait time, but Cloud Run is trying to maintain like pre-warmed instances. It's trying to keep them running even if you're not using them. But you're again not gonna be charged because even though the instance is running it's not handling any requests, and you pay only when the instance is running and handling requests. So yeah, they're trying to work out that bit with having pre-warmed running instances. Yeah, cool.
Last question now, all right? Because everybody's hungry, we have lots of food, and we want to get you out here so we can cool this room down for the second session.
I don't know if you were here for Jay Campbell's presentation about service reliability engineers. I think that's what they call it, where they're the ones that monitor the system, and if something goes wrong, the example he gave was the latency. So the front end was starting to fail because there wasn't enough latency. But if you're using this services thing, my understanding is that it does all that for you. So if there's problems with resources, it automatically creates another instance, and then as a result, then so if you use services, you don't need an SRE, a service reliability engineer. Would that be a correct assumption?
It will typically try to scale and then scale down, but yeah, you still want to monitor what's happening there. But yeah. Yeah. If you don't want to pay for a service reliability engineer.
We have a lovely hoodie
Thank you.
for you. I don't know if you want to trade your MongoDB one, but thank you so much.